Hi, my name is Steve and I'm here to do a quick demo on the features and functions of the Smart Manifold, which is an accessory that, as you can see, fits underneath the standard hydraulic burst leak tester from Crescent Design. I've also put a laptop PC up here running Windows and our pressure manager software so that we can see in real time what's happening down here. So the Smart Manifold is an accessory that you can see is attached, hydraulically attached to the HBLT, and it has 10 ports, and they are individually selectable, and they may be selected in any order that you find useful. And when you run a test on the HBLT, it will run a test on the ports either individually or in parallel, all at the same time, or sequentially, one port after another, starting at whichever port is selected and working its way up until it's done. There are a number of different tests that can be created. I'm going to quickly go in here so that you can see some of them. These are new tests, and I'm not sure how well it'll show up, but maybe on a bigger screen you'll be able to see it. It has a linear ramp, a staircase, fatigue, incremental, custom, and group. Some of these you'll be familiar with testing you may already be doing. Linear ramp is when it starts at 0, goes to a target pressure at some programmed rate for some programmed period of time, and then back down to 0. And when it reaches the target pressure, it can look for leaks, and it may look for, or will look for, bursts at any time, going up, maintaining, or going down the other side if that's what you choose. And then other tests can be created by linking these ramps together, these pressure profiles together. Staircase, where it continues to go up in pressure. Fatigue, where it repeats the same pressure target and ramp rate over and over as many times as you choose. Incremental is a variation on that. Custom allows you to create a completely arbitrary test with up to 100 different pressure values, either positive or negative. And we also have a group test which allows you to link up to 10 of these different tests together and then run them sequentially automatically. So again, that can all be run with just the HBLT and the Smart Manifold, but with the addition of Pressure Manager, one, you get to see in real time the pressure versus volume over time as it's displayed on the screen as the test is being run, and you can write scripts in Pressure Manager that allow you to do different testing, additional testing that's not possible with just the basic HBLT. So the first test that we're going to run, we're going to do a leak test, and I'm only going to choose the first 3 so that you can see how it pressurizes, how it fills, then it pressurizes, then we will create a leak, and you'll see how the Smart Manifold finds the leak. And I could run it just from the HBLT, but I want to use Pressure Manager so you can see how that works as well. The first thing we have to do is select the ports, and we can do that manually with just pushing the button, or we can go up here on the screen and select it right there. So you can see now we have 3 connected. I'm going to open this port 3 right here because we need to do a fill. So I have chosen a test called ITW leak, and I'm going to hit start. Okay. So the HBLT is now positioning itself internally, making sure that it has a complete cylinder of water in order to do the test, and it's now going to start leaking, and I think you can see it leaking right here, so I'm going to turn it. So you would do that in order to fill your product. You could have as many as 10 products, and so long as you could fill them and close them off, Eventually you would close them all off, the pressure would rise, and it would then reset itself as it's doing right now. Okay. So I've got my little leak that I've created right here as another stopcock, and I'm going to wait for the cycle has started, so it's going up to target pressure right now, and it's going to maintain it for a short period of time. The maintain's done, and then I'm going to open up the leak, and you'll notice that it detected a leak tip right here. So this information is displayed here, but all of the same information and more is displayed on Pressure Manager up here. And you can see the graph that's been created as it created the pressure, and then the pressure dropped, and it detected that as a leak. So it's now pressurizing port 1, and port 1 doesn't leak, so it will pass the leak test. And then it will move on. So now it's moved on to port 2, so now it's going to look for port 2, and it will pressurize it, or it will attempt to pressurize it. And you can see it's leaking right here. And you'll notice that it took it offline because it found the leak, and it's now moving on to pressure test the third port. Now there is a possibility that multiple ports would leak, and so it would simply work its way down the line looking for the leaks until all of the ports that had been selected had been tested. So here we're doing the pressure test on port 3, and it's succeeded, and the test is now complete. And what you see here is a graph of both the pressure and the volume. It's difficult to see, I know, on that screen. The two different colors represent. We now have it complete. You saw the report scroll up, and it reports on a leak dip failure on port 2, and the max pressure was 48. The pressure when it failed was 42, and then it goes on to report that there were no failures on port 1 and port 3. So that's the, and you can also see, I might add, over on this representation of the Smart Manifold, you can see various data being reported there, including the volume as well. So that's how a leak test is done on a Smart Manifold, by pressurizing them all. If a leak happens, we shut it down, all the ports, and then we start hunting port by port until we find the leak, take it offline, and continue till we've established that all of them, the rest of them, have either failed or they have passed. So we're going to move on now and do a maintain test. We'll do that in just a minute. Thank you. Here's a close-up of the last screen on the HBLT, so you can see the data that's presented there. And here's a close-up of the PC screen showing the various screens that we show in Pressure Manager. Okay, we're back, and this time we're going to run a different test. We're going to do a maintain on 3 ports. Again, it could be on multiple ports, but I thought first I would show you some of the features of the software built into the HBLT. So why don't I show you the test I want to run next, and it's called ITW Maintain. Normally we would just go through the run screen, and you can see there's ITW Maintain right there, but I want to show you how the test is constructed. Normally we would start it new to create a new test, but here let's edit the existing one. Let's go to ITW Maintain, and here it gives you an overview of the test. You see there's the name, it's a linear ramp, it's pressure PSI, And you could put product ID in there, which we didn't do, or the engineer ID. And here's compliance, and that's a measure of the product's elasticity. Here, since we're using stopcocks, they're very rigid, and so we use a setting of 1. The fill speed. Now here we're not going to use a fill speed. You see it's set to none because in the previous test, which would be run prior to this test, could be, we did fill. So the products are already filled. So we're going to skip over that one. The target pressure is 45 psi. The leak rate is 10 psi per second. The leak dip, there's no leak dip setting for this. There's an upburst rate of 100 psi per second. There we have no downburst rate. Most products fail on the way up or during the maintain, so it's not really necessary on the down, so we say none. The up rate is 10 psi per second to the target pressure. The down rate is 50 psi per second. If the product survives, then it'll just come back more quickly. But it is programmable, and I would point out, you'll notice that we provide you with a minimum setting and a maximum setting. It will not permit you to go outside of those parameters on this particular model. This is a model 1000. The dwell time, that's the period of time that it's going to be at the target pressure. In this case, 30 seconds. But please note that it could be up to 999 seconds or 16 plus minutes. If that was not enough, you could elect to use Pressure Manager, in which case you have a virtually unlimited amount of time that it can spend at any particular pressure. Maintain. This is the amount of time that is going to maintain the pressure at the target. And we do that so that if you maintain a shorter period of time than you dwell, that allows you time to look for a leak. But in this particular case, we already looked for the leaks previously. We've removed them from service. So now the only thing we're concerned about are bursts. So in this case, we've just set it, I've set it for the maintain for both 30 seconds and the dwell for 30 seconds. And again, I want to point out, I'm going to go back so you can see that, the dwell could be 999 seconds. So it could be very long. And some customers want a long period of time to be maintained for a long period of time. So we'll leave that at 30 seconds so that we're not waiting a long 15 minutes or so. The maintain is 30 seconds, as I said. We're in the parallel mode. And in this case, all of the ports are pressurized at the same time. We could choose sequential, in which case they would the test would be run sequentially from one port to the next. Or it could be set for a single mode, in which case the test would only be run on one port and then the test would end. Okay. These numbers here, these settings here are for finding a leak or a burst. And these allow you to set, this particular case is the purge rate. This is the amount of time. If you had a burst or a leak, this is the rate at which it would pump water into each port, and it would look for 5 seconds to see if the port reaches 5 psi. If it does reach 5 psi in less than 3 seconds, or 3 seconds or less, then that port is good. If it is leaking, then it would never reach this target pressure, and then it would be declared a failure or a burst or a leak. So that's how we find the leak on any given port. Okay, and then multi-port compliance. We said earlier that the compliance is about the product's elasticity. The elasticity is the sum of the number of ports that you have selected. So if you had 5 or 10 ports, the elasticity, or what we call compliance, would be the sum of all of them. And as they fail, the software in the HBLT dynamically changes the value to make sure that the test results are repeatable on each port. Okay? And then in our case, we're only using 5 ports, and so we've selected 5 ports there. Now, it didn't ask me to change anything because I didn't change anything. If I had changed the parameter, it would have asked me, do I want to keep it or change it and give it a different name? So I'm going to return back to the main menu, and then we're going to restart so you can watch it run this test. And I'm going to cause a burst to occur on one of the ports so that you can see it, look, and find it. Okay? Okay, let's run a fatigue test with a burst on port 2 here. So I've already loaded ITW Maintain up here, and we're going to use Pressure Manager so that we can see it happening. So the first thing, as I did before, I have to select the ports. I can do it manually, or I can go up here and use the PC Pressure Manager to select the ports. And now I am ready to start. Okay. And I have a hose attached to this port so that the water goes into the trash can rather than on my lovely assistant behind the camera. Okay. So we're now maintaining during 30 seconds of this test right here, and I'm up to, I don't know, let's call it 10 seconds, and I cause a burst. Okay. So I've opened this port right here, and there was a sudden pressure drop, which the HBLT interpreted as a burst because of the pressure, the rate at which the pressure dropped, okay, not a leak. And we can see that on the screen here, and I just got sprayed, but I'm used to that. And I don't know if you can see, it's the water's coming out, and you'll notice that it took it offline. So it's determined that this port is leaking as burst, and it's now moving on to test the third port in the same way it tested the first port. Okay, so that port is good, and okay, so it's going back up to the original pressure that we had set. Now in this case, it reset and it's doing it for 30 seconds. Okay, so, but it is possible if you want it to pick up where it left off. So we went 10 seconds. If you wanted it to only do 20 seconds, we could provide that with a different piece of software called Lab Genie that can give us a lot more control over the various features and functions of the HBLT. But this basically shows you its basic function, how it works. So we found the burst port, we tested the other two, and we restarted and completed the 30-second test. So that's how a maintain test is done with a burst, and you can see how it found it. So next, let's go on and do a sequential test, burst test on each port. Okay, we're back to do a sequential burst test here. Now, again, to repeat that you could do this on up to 10 ports. We're only going to use 3 ports so that you can see we don't want to wait for that to complete, but you'll see how each one goes to a certain target pressure. I will simulate a burst, it will detect it, and then move on to the next one. I already have one programmed in here I'm calling ITW Burst. It's already loaded, and I have to pick the ports manually, or I can go here and turn them on from there, and we're now ready. So here we go, we're going to hit start. Okay, so you notice it's going to port 1 first. Okay, and I'm going to burst it around 150. Okay. And I'm moving the lines once again so we don't get the lovely assistant wet. Notice it took this one offline. It's now moved onto this one. Target pressure is going up. You can see it right here. Okay. Found it. Took this one offline, and now we're going to move on to the next port. Okay, here goes the pressure is coming up. Let's go to like 175 and see what happens right about now. So, and here you can see the individual pressure ramp rate, the target pressure. We went off scale here. I can show you that I can reconfigure that so that we'll say okay, and now we get to see more of the traces here. We can do that numerous times to get what we want in view. This data is available to you in comma delimited form so that you can put it into Excel or other spreadsheets. Here's the report that shows the failure on each port, what pressure, what time, how far into the time period, and here's the results here on the representation of the Smart Manifold, including times and volumes as well. So this was a short demo of leak detection, kind of a fatigue test, a pressure test, simulated a burst, and here we have done a sequential burst test. This system is capable of a tremendous number of other tests, variations on a theme, and the data can be collected and displayed in any number of different ways. And with the advent of LabGenie, we can do virtually any kind of testing that you can imagine, including adding external devices to do additional testing as well. So if you have any other questions, please contact us here at Creston Design, and we'd love to help you with your testing. Thanks.